Welcome to fourth hour. No, I'm not going to talk in a weird voice. Okay. So on these problems, every single one of them, we have to find the first and second derivative, and then we're trying to determine where the first and second derivative are positive, negative, and changing between the two, positive and negative. So on this one, we have to find the derivative, and the derivative can be found easily with product rule. First function is x. The derivative of natural log is 1 over x, plus the derivative of x times natural log of x. Okay, so we get a first derivative here of 1 plus natural log of x. Okay, and it's really important on this problem to identify that natural log of x isn't defined for all real numbers, right? So natural log of x only happens when I have positive numbers. Can't take the log of 0, can't take the log of a negative number. So if we just kind of put a little note up here that f of x is only defined for x greater than 0. Okay, so we don't really even have to think about negative numbers in this problem. The function's not going to be defined for negative values, right? I can't put a negative number into this function. All right, so when I'm taking the derivative here, again, I'm considering that like I'm not worried about negatives. I'm not worried about this being negative. I'm trying to figure out when this equals 0. Okay, so I found my first derivative. Right now I am looking for critical numbers. I'm looking for critical numbers. Okay, and so I subtract 1 from each side. I get natural log of x equals -1. And then natural log of x is log base e. So if I do e to the negative first power, I get x. So when x is e to the -1, also known as just 1 over e, then the derivative is going to be 0. Okay, so this is my only critical number. Okay, that's my only critical number. So I go, and then the next thing that I do is I make my number line. Okay, now with this number line, again, I've got an open circle over here at 0, and I'm going to infinity. I'm only going to worry about numbers that are in the domain of my function. I'm not going to concentrate on negative values. Negative numbers don't make any sense in this problem. Okay, there is one number that was a critical number at 1 over e. All right, and now my job is to pick some kind of value on either side here and see if the derivative is positive or negative. Okay, so finding a number that is bigger than 1 over e, that's easy, right? Like I could do 1. 1 is a very convenient number to put into the derivative because if I take natural log of 1, it's 0. All right, so I'm going to test points on each interval. Again, smart point to choose is 1. F prime of 1 is 1 plus natural log of 1. Natural log of 1 is 0, so we're looking at 1. The derivative is positive. This is a positive interval over here. Okay? Now, I've got to find a number between 0 and 1 over e. E is like 2.7-ish, yeah? So if I chose a number that's less than 1/2, I would be okay, right? So I could choose something in here like 1/4, sure.
Toby?
Yep,
Yes, could you please send Addison Schroeder to the office with his things?
I can do that.
Thank you.
So if I take the natural log of 1/4, natural log of 1/4 is going to be what? Do you have any idea? Is there anything that we can take the natural log of where you would have an idea? All right, so let's try this. Okay, would you agree with me that 1 over 2e is less than 1 over e? Because I'm making my denominator bigger, and so like it would be a smaller number, right? So this is a number that is between 0 and 1 over e. So if I do f prime of 1 over 2e, I'd have 1 plus the natural log of 1 over 2e. Okay, now you're like, no, thank you. Okay, so, maybe I think about it as 2e raised to the negative 1. And then I pull a negative out front. And then maybe I think about what that would look like. So I'd have 1 minus natural log of 2e. Like natural log of 2 plus natural log of e. This is 1. Seems like I would get a negative out of this. Okay? Now, honestly, feel like a lot of people go into Desmos, right? Just type something in. But if you're going to do that, then you might as well just do the whole problem of it, right? But like if we're going to do this, if we do 1 plus natural log of 1 over 2e, we see it's a negative number. You're going to get a negative value there. Okay. Another value you might want to consider putting in is like an e squared. If you put in e squared, then it's like e to the negative 2. You could pull out a negative 2. Bottom line is like all the derivatives over here are going to be negative. Okay. So now what does that tell me? Okay, that tells me that my function looks like it would be increasing here on the interval from 0 to 1 over e. And then it will be decreasing, no, other way around. See, this is not video quality. Decreasing from 0 to 1 over e, and then it's increasing. We have positive derivative for all x greater than 1 over e. Okay, and if it's switching from negative to positive, my derivative, we have a relative what there? Minimum or maximum? Minimum, okay? So we're switching from negative to positive. So we have a relative minimum at 1 over e. Okay, so again, decreasing, we're looking at when f prime is less than 0. Increasing, we're looking at when f prime is greater than 0. And we're talking about the original function, x natural log of x. That is increasing or decreasing. Okay? Any questions about first derivative? No. Okay, second derivative then. Okay, so my first derivative is 1 plus natural log of x. When I take the second derivative, I get just 1 over x. And again, they're not really critical numbers when we're talking second derivative, but I'm still looking for values. I'm still looking for x that make f double prime 0 or undefined. So I know how to divide up my number line. In this case, x equals 0 would be that number. Okay, 0 makes the second derivative undefined. But again, going back to my number line thinking, 0 is not even something that I could put into the original function. So there's no real like questionable values between 0 and infinity. So there's just one interval here. Okay, now is my second derivative, when I put positive numbers in for x, is my second derivative positive or negative? Positive, so it's just always positive. Okay, if it's always positive for a second derivative, that means my graph of f prime, no, my graph of f is always concave up. And there are no points of inflection because there's no places where it changes concavity. Okay, so if I go and I decide to throw this graph into Desmos, x natural log of x, I should see a transition point at 1 over e where there is a minimum, where it is switching from a decreasing function to an increasing function. And then I should see a graph that always looks like it's concave up. Okay, so let's graph this and actually see if that's what happens, right? So f of x equals x, natural log of x. Okay, graph is undefined over here. It looks like there is a minimum. It looks like a Nike swoosh. Okay, and we have a minimum point. Okay, let's see where that minimum point is at. Minimum point is at 0.3678. I bet you that's 1 over e. Let's see. Okay, is that 1 over e? 0.3678. That's where that minimum is at. Okay, so that works. Concave up everywhere, decreasing for the first part, increasing. Found that we have a relative min there. Are there any questions at all about what we did with any of this? Can I stop the video at 11 minutes? Yeah, we can.